Of course, drug users are not thinking about adaptive changes in the structure of their postsynaptic receptors when they use a drug. Rather, the drug user is experiencing something pleasurable and reinforcing like euphoria or relaxation. These pleasurable and reinforcing experiences involve the dopamine system in the brain and an area that has been named the pleasure center. The pleasure center is a dopamine pathway between the ventral tegmental area, or VTA, and the nucleus accumbens. It is most likely the site for the rewarding effects of natural rewards like eating, drinking, and sexual behavior, as well as the site for drug effects like euphoria and pleasure. The pathway from the ventral tegmental area to the nucleus accumbens seems to be most active when unexpected and potentially reinforcing events occur. An example of an unexpected and potentially reinforcing event would include the focused, alert feeling you experience the first time you drink a cup of caffeinated coffee in the morning. The ventral tegmental area receives input from the prefrontal cortex. Many executive functions like planning and goal-directed behaviors are localized in the prefrontal cortex. Neuronal activity in the prefrontal cortex may signal reinforcement value to the ventral tegmental area, which subsequently informs the nucleus accumbens with phasic bursts of release of the neurotransmitter dopamine. Regions of the limbic system, namely the amygdala and the hippocampus, influence the transmission of information from the VTA to the nucleus accumbens. The limbic system's functions include regulation of the nervous system's responses to emotional stimuli. The limbic system also plays important roles in motivation, reinforcement, and memory. Chemicals or behaviors, such as cocaine or gambling, which activate the limbic system, are likely to be associated with pleasurable effects. All drugs with addiction potential have pleasurable effects. Two aspects of pleasure associated with drug use are the expectation, craving, or anticipated pleasure, and the hedonic value or actual amount of pleasure experienced. Let's explore exactly how the pleasure center, also known as the dopamine brain reward system, operates. Generally, the release of dopamine in the nucleus accumbens is maintained at a steady or tonic level because neurons in the ventral pallidum, VP, which receive tonic inhibitory GABA input, inhibit dopamine release by the VTA. The result is a steady tonic release of dopamine in the nucleus accumbens. The prefrontal cortex communicates with the nucleus accumbens via the neurotransmitter glutamate. When the prefrontal cortex is activated, for example, when you experience the relaxing effects of alcohol and interpret the associated feeling as relaxing or pleasurable, glutamate from prefrontal cortex neurons is released into the nucleus accumbens, resulting in the nucleus accumbens releasing GABA to the ventral pallidum. GABA suppresses the usual inhibition of the ventral tegmental area by the ventral pallidum. This suppression of inhibition results in a phasic release of dopamine from the ventral tegmental area to the nucleus accumbens, signaling positive reinforcement value of current experiences, which is the pleasurable effects of alcohol. Dopamine has also been shown to play an important role in the stimulation of long-term potentiation, LTP, in the hippocampus, a potential mechanism for the establishment of new learning-induced neural pathways. We learn to associate drinking behavior with a relaxed feeling produced by the alcohol's indirect effect on the nucleus accumbens. Scientists are studying the components of reward mechanisms, namely liking versus wanting. A series of studies by Smith and Berridge, 2007, and Robinson and Berridge, 1995-2008, at the University of Michigan, indicate that dopamine is the transmitter involved in the wanting or craving aspect of reward behavior, but other transmitters, like the opioid transmitters and GABA, mediate the liking or pleasure aspect of reward behaviors. Following chronic drug exposure, activity in the wanting and liking pathways may become disconnected from each other or uncoupled. Normally, we crave what we like and like what we crave. If these two systems become uncoupled, then we may no longer like or enjoy what we crave. For example, chronic drug users experience intense craving for a drug, but no longer experience the desired amount of pleasure following drug administration. That is, the drug user can develop tolerance to the pleasurable effects of the drug. Many drug addicts crave substances that have destroyed their relationships and lives, and from which they no longer receive much pleasure. This image shows how different drugs of abuse act on the ventral tegmental area and nucleus accumbens to agonize dopamine. Some drugs, like cocaine and amphetamine, increased postsynaptic dopamine effects in the nucleus accumbens. Alcohol and the benzodiazepines agonize GABA in the ventral tegmental area, which disinhibits ventral tegmental area dopamine activity in the nucleus accumbens. Drugs such as PCP, commonly known as angel dust, affect glutamate receptors, which results in increased dopamine activity in the nucleus accumbens. Other drugs like heroin and morphine stimulate opiate receptors in the nucleus accumbens, which then stimulates dopamine release in the nucleus accumbens. Regardless of why people initiate drug-seeking behaviors, and regardless of their initial expectations of drug effects, all substances with addiction potential activate the brain's reward and pleasure centers. According to the final common pathway model, all drugs of abuse either directly or indirectly increase dopamine activity in the mesolimbic dopamine reward pathway. Chronic drug exposure may lead to changes in neural adaptability mechanisms associated with drug withdrawal effects, as well as unique effects on the brain's wanting or craving systems versus the pleasure or liking systems. Such activation of the brain's reward systems most likely accounts